Hey guys, this is Fred from Pretty Fly Games, and this is a new network series where we will cover Photon Quantum, which is now free for everyone to use. Photon Quantum is a network solution which is very different from Photon Fusion or Unity netcode, which is state synchronized. So with Photon Fusion, the clients and servers are trying to stay in sync, but in fact they are never 100% in sync. While on the quantum side, as it's deterministic, it means that all the clients are actually in sync all the time. So a simulation, a physics simulation, will be the same on all clients. And you can even do things like a replay where it will be 100% accurate. So how it works is that you have your network stack in the bottom, and it's actually sending the input between the clients and it's passing through the quantum server. So quantum is running in the Photon cloud, which is also a benefit because you don't need to have your own servers. So quantum ensures that all the clients are running the simulation and are in sync, and that the input is provided between the different clients. And Unity in this case is just acting like a viewer. So Unity is just responsible for rendering the graphics. And you can actually use other game engines. So you can use Unreal, or you can even use Godot that Photon is working on adding a viewer for. So which network solution should you pick? Quantum or Photon Fusion or Unity netcode? Well, if you're deciding between Quantum and Photon Fusion, then you need to think about what type of game you're creating. If you're creating a first-person shooter, then you will want to use Photon Fusion because it is created to handle a lot of clients, up to 200, and it also has support for lag compensation raycasts, which is needed when you're running first-person shooters. Quantum does currently not have that. It is coming in version 3, but right now it doesn't have it. But the benefit of Quantum is that it can handle a lot of units, because the units are not synchronized across the network, only the input is sent across the network. So if you're creating a game which has a lot of units, or that you have sort of weaker devices like mobiles, then often Quantum is the solution you want to use. And as I said before, the benefit is that you don't need to have server orchestration. You don't need to handle servers at all. So for instance, Stumble guys are using Quantum, and they don't need to worry about server management or anything like that, and it can run on mobile, but it can also run seamlessly on PC or console. But there is a downside to Quantum as well, and because it's a complete game engine, it means that all the game logic and everything that is happening in the game world needs to be written inside the Quantum engine, which is using ECS, actually Photon Quantum's version of ECS. So that means that you will need to learn this new system, and you need to use all of those components, which is very different from what you have in Unity, and it is a lot harder. So with that said, let's actually jump into Quantum and let's see how you set it up and how you get it to run. To get started with Quantum, the first thing we need to do is download the SDK. So go ahead and click the download and then extract the content of this zip file into a folder. So after you extract the files, it will look like this. So you have one code project, which is Quantum Code, and the other one is Quantum Unity. Quantum Code contains the Quantum game engine and the ECS code that you will write to manage your game. And Quantum Unity is the viewer, where you're seeing all the graphical stuff in your game, and that is a separate project. So now you have to work with 2 projects. And if you're upgrading an existing game, it's a bit of a challenge because these needs to be set up, but there is a guide for it on the Photon website, so go and visit that. So let's start by opening up the Quantum project in Unity. So when we open the Unity project, it looks like this. So we are already provided with a Photon folder, which contains our Quantum demo. And actually I created a folder called materials, so that's not included, but yeah, it's just regular Unity materials in different colors. But the interesting part is this Quantum demo. So Quantum demo already contains a game and menu folder. So the game folder is actually where our game is going to run, and the menu is just a menu where you can join a room and set your username, etc. So let's start by looking at the game. So if we open the game, it looks like this. So we have a Quantum stats game object, which is a UI thing that shows the stats in the game, and it looks like this. And then we have a script that collects local inputs and sends it to the Quantum game engine. And then we have something called entity view updater, which keeps all the entities graphics updated inside Unity. So it takes the entities from the Quantum game engine and renders them in Unity. And then we have some map data and a debug runner and just regular lights and camera. So now if we want to create a level, let's start by actually getting rid of our Quantum stats here because I don't need them. We need to create not a regular game object, because a regular game object only exists on the Unity side, and we need a level, so we need something that actually exists in the Quantum game engine. So we need to create an entity for that. So let's go into right click Quantum 3D, and we'll start by creating the ground, which is going to be a static box collider, and we can call it ground, and let's make it a little bit bigger, maybe 10 times 100, or actually let's make it even bigger, and then we'll focus on it, and let's make it green. All right, and as we are moving around, we can see that it flickers, and that's actually because of the gizmos drawn by Photon Fusion, and we can disable that by hitting gizmos here, and now we can see this is how it's going to look sort of in the game. But the gizmos are good to have active from the start. And then we want to add some obstacles in our level here, so let's go with some more static box colliders, and let's actually bring them. Or actually, we will have 0, 0 as the sort of the starting point for the player. So something like that. And our box collider, let's make it blue. And put it somewhere on the ground there. And maybe we want to have some more obstacles, so let's make some bigger stuff. And maybe we want to be able to jump on the first one and then reach the second one. So that's our level for now. So it looks like this, and let's just update our camera. So I don't know, let's have it, let's start by facing just these objects. Select the camera, go game object, align with view. All right, so our game camera is now the same as our view here. Okay, perfect. So let's add some physics objects so that we can see that it's actually working. So Quantum 3D, and then we'll make a sphere entity. And in our sphere entity, let's enable physics body 3D. So remember, we need to use the physics system in Quantum and not Unity's physics system. And then let's make it 2. And where is... Oh. So 0, 0 is actually here. Alright, so that could be good if our ground is actually close by, if we're spawning the player at 0, 0. And let's actually move it down. Alright, so here's our sphere, and let's make it red. And now if we hit play, we should have some physical simulation going on. And as we can see, the ball fell down and it, well, rolled on this surface. And, well, looks like our cubes are actually floating now. So let's just quickly fix those things in our scene. That's good enough. So now we have our quantum world, which is working, but it's not very interesting because we don't have a player yet. So we want to create an object that the player can move around in the scene. So we will go with a 3D character controller entity. And let's go and have a look at that one. So it looks like this. And the character controller is a little bit different than what we're maybe used to, and we can pair different things under it. It's right now a sphere that looks like this, and we can essentially add different type of objects to it, but it's still going to be a sphere based entity. So it's not the regular pill that we have. We have the shape here, which is sphere, box, mesh, terrain, compound, and we are going to use a sphere for our character. So let's just keep it as it is, and we will change the color to red for it. Hold on, material, red. Here we go. And the reason why it's not looking red is because we have our gizmos that are drawing over our color right now. So it is red, trust me. And maybe we should change our physics object here to yellow, so we're not confused what the player is and what that thing is. Alright, so let's just move it here. So now again, if we hit play, we will see that we have our yellow physics object. It's falling down, it's moving, and we have our player here, which is actually not moving. And the reason is, the reason is because there is no sort of thing in the world, in the game engine world, which tells it what it should do. So what will happen then? Well, nothing. It will not do anything by itself. And as well, another important thing that I forgot to mention was that, okay, I scaled this sphere up, but as you can see, it actually now is going through the ground a bit. And the reason is you can't simply scale things like I did, like here, increase the scale in Unity, because that is only changing things on the Unity side. So we need to look at the entity prototype and see what information does that have. And we can see here inside there is an outline, and that is actually the size of it. So if we want to increase it, we need to increase the radius here, and then it should no longer penetrate into the world. So now it actually looks correct. And the same goes for, well, everything inside the game world here that we have. We need to make sure that the entity is set up properly, not actually how the view looks, which is transform. Okay, so now back to our problem with our character controller that doesn't do anything. So for it to move, we actually need to provide some more information inside Quantum's game engine, and we need to write some ECS code. So we need to open the Quantum project. So let's go and have a look at our location where we actually put our Quantum Unity, and above that we have our Quantum code. So let's open that in Visual Studio, which is a separate project. So when opening the project, you might get a view like this and telling you to update the target. So just do that. And if you're missing .NET Framework 4.8 or anything else, make sure that you install it. So there we go. And that will update our project, and it will take a little bit time, but here we are. So now it's actually updated. So in our project we have a few files here, runtime, player, etc. And we won't actually do very much with those so far. Rather, we will create our own entity system, component system, that controls the movement of our player. So let's create a folder, add folder, and we'll call it movement. And under movement, let's add a script or a Visual Studio, what am I saying? A regular C# file, and let's call it movement system, and open it. And so it looks like this. So let's delete our internal class and let's make it part of the namespace Quantum, and then we need to add how it needs to look to work in Photon Quantum. So we have a public unsafe class, movement system, and it's a system main thread filters and include the movement system filter. So we have an error saying that we have not implemented the abstract member update, and we can press show potential fixes and then just implement it. But we still have an error saying that, okay, I don't know what the filter is, so we need to add our filter. So a filter, what it does in Photon Fusion is that the filter will dictate which game object we are updating. So this movement system will actually try to interact with all of the objects that exist in Quantum. So we need to filter out specifically what object we are looking for. It does not work like the Unity component system where we are attaching things to a game object. Here it's sort of you're interacting with every object in the whole world, all entities. So we need to filter out specifically what entity we are trying to modify or interact with. So what type of things are we looking for? So first of all, it needs to be an entity ref. So we have a public entity ref. And then we want it to have a character controller. All right, so let's add our character controller. So character controller 3D, and it needs to be a pointer as well. So everything is pointers where we're interacting in the ECS of Quantum. And then we need a transform so that we can change the transform of this component. So, and luckily in our world we actually have one entity that matches this criteria. So we are sure that we will get our character controller in the scene. So now we can actually move our character. So let's take our character controller. So we need to go filter dot character controller. And then since it's a pointer, we're accessing a pointer here, we need to use this way of accessing it. And there is a function that we want to access, which is going to be move. So we wanted the character controller to move. And first it takes in a frame. So let's take in our frame that we got here. And then it says, okay, we need an entity ref. So that's our filter dot entity. And then it needs a photon deterministic FP vector 3 direction. So in Photon Quantum, there are no floats or doubles. It is just using regular integers to represent the game world. So they have added their own math library to create vectors and things like that that are only based on integers. So this is important. You need to use their versions of vector 3 and other things like floats, etc. So do not create your own floats, because that simply will not work. And this is required because the way of Quantum is that it's a deterministic engine, and integers is the only thing that will work cross-platform with different computers and stuff like that. So let's add using Photon deterministic, so we can access the FP vector 3, and we want the object for now, to just move forward. All right, so let's save that. And let's make sure that we type correctly. Then we need to actually have this system work. So go into system setup, and user systems goes here. So we need to add it. New movement system. Okay, so let's save that, and then let's build our solution. Every time we make a change in our code here, we need to build it. All right, so let's jump back into Unity. So if we hit play, we should hopefully have some action now. All right, so our character controller actually moved, and it fell down onto the ground, and then it moved forward and ran into this other box. So let's just move it out of the way, and so we can see that it continues to move. All right, so here we have our little ball rolling, and this is our character controller, and this is our physics object. And again, we can't control it with any of the buttons, so it's not very much a game so far. So let's add so that we can control this character controller with our keys. And again, we need to build this in the Quantum side and program some more ECS. So let's jump back into our Quantum project. So to handle input inside our Quantum project, we need to first create a new folder, because we need to use a specific let's call it input, a specific file called a QTN file. And a QTN file is a Quantum specific language. So it's the syntax is available on the SDK's website, but it sort of it reminds a little bit of a struct and how that looks. So we're going to have input, and then we are going to have some values, or actually we're going to put it like this. And what we want to define here is how our values will look, or how our input struct will look. And we want to be able to send input, and we want to optimize it a little bit. Instead of just sending a complete vector, which you can do, you can set in a vector 2. Instead, we're going to use two shorts. So we're going to have a short direction X. So when somebody in Unity, normally when you are using get input, you are getting a value between 1.0 or actually -1 to 1.0, right? So what we're going to do is we're going to multiply that by 10 to make it into an integer, because we are only interested in one decimal. And when we are reading it, we're dividing it by 10. So that's a little bit of an optimization. You could use a vector right away. Just make sure that it's a FP vector and not a regular one. All right, and then we have direction Y. And actually, then we want to be able to jump. So we'll add a button jump. Actually, we'll just do it like this. I think it's easier to read it this way. All right, so then we have this, and to be able to use it, we need to compile it. So let's go build, build solution, and this will find the QTN file. So I think it says somewhere here when it's generating, yeah, that it found it, input QTN, Photon Quantum DSL file. All right, so that's good. Now that we have that file, we can actually start to use input here in our project, and we are going to look for the input from a player. So we are going to say, okay, var input is equal to, and then we are getting the frame. So we're going to do f dot get player input, and this will want a player number, so we're just feeding it 1 to start with. And now our input is containing our direction X and direction Y. Neat, huh? But now we can't use this directly because we have encoded it into our special integer, right? So that was multiplied by 10 on the Unity side, which we haven't done yet, but we will do. So we need to create a new variable, and we'll call it input vector, and we are going to decode our input value here. So what we're going to do is we are going to make a new float point vector 2, and it will be input, and from it we will take direction X, we will divide it by 10, and then we will take our input direction Y divided by 10. Okay, so the problem though is if we do this, it will actually be an integer, and we want it to be a float point. So we need to cast it. So let's cast it into a float point. And again, here we need to use Quantum's floats and not some other float from the system. Okay, so now we have our nice input vector here, and instead of providing move forward, we are going to move in the direction that we have provided here. And so we can just feed it in there and see what it says. And it will give us an error because it says, okay, I can't convert from a float point vector 2 to a float point vector 3. So let's make a new float point vector and input vector dot x, and then we are going to give it 0 in the y direction and input direction y, and then close it up. Okay, so now we are actually able to move in this direction. So that's one way of doing it. Another way is making it a little bit easier is we can take our input vector here and we can take x, o, y, x, o, y. So that returns x, 0, y. That's nice. And just need to figure out why it's showing an error here. Oh, sorry. Because I declared it as a variable here, then it's not really a pointer. So now we have that value. There is, however, one little thing, and that is now a client can cheat. Because if from Unity they sort of hack the code or do something and they send in an extremely large value, like 1 million, then their character is going to move very, very fast because we are just putting it here. So to reduce the risk of this, we are actually going to put in a little bit of an anti-cheat. What we're going to do is if our input vector square magnitude is larger than 1, then we are going to reduce it. So we will take the input vector and then we will take our input vector again and we will normalize it. So no matter what they're providing here as an extremely large value in the input, then we will check that if it's bigger than 1, then it will become normalized. So it will become between -1 and 1. So that's fine. Now they cannot cheat. Okay, so if we save this, we compile it again and try it in Unity, it should actually work and we should be able to move the character. But if we play it now, it wouldn't really work because we need to actually sort of read the input stuff from Unity and send it to Quantum. So if we look in the Quantum demo games scripts, we will see that we already have a local input. And that is actually what is running here. So we just need to modify this script a little bit. So if we look at it, it has a poll input here, which is yeah, actually what we're after in a way. And this has read in our file that we had before, and I will just see what is up with some of the formatting here. All right, there we go. And so we have I dot and C. Here is our file, the QTN file that we had before. It's taking the direction X, direction Y, and jump. So we'll start with jump. So we need to provide a way of determining if we're jumping or not. So what we're going to do is we're going to use the input system from Unity. So we go Unity engine.input get button and jump. Okay, then we have our other part, which is going to be our vector 2, right? So we have our input vector direction, and we are going to just take in the axis. So we're reading in the axis input direction X and Y. So then it actually needs our input dot direction X, which is going to be our input direction dot X times 10. And this was a short, so let's cast it into a short. There we go. There we go. So I need to correct that error. And again, the whole thing, we need to cast it into a short. So that should encode our input properly. And then on the other side, we are decoding it. So, and I did a mistake. Direction Y. So direction X, direction Y. Okay, so let's save that and try it in Unity. Alright, so now if I press W, it goes up, and S, it goes down. And it is a little bit sluggish to change direction when I let go of the key, and that's because of Unity. So let's actually change that. So project settings, and hold on. So my project settings, let's just stock it here. So I will go into input and wherever it is, input manager, axis, find the horizontal, and the gravity is set to 3. So let's set it to 30, and vertical gravity, let's set that to 30. So then it will be snappier, and then we will just close the tab again. Make it. All right, so if I try it now, it should be faster. All right, yes, now it's snappier, and let's see if I can jump. No, we can't jump. And why can't we jump? Well, because we forgot actually. We are reading the input, we're sending the jump button, and but we are not doing anything on the quantum side. So let's quickly fix that, save this, and go into quantum. So let's add jump. So we are going to check if input jump was pressed. Nay, sorry, was pressed. And if it was, we are going to do filter dot character controller and then jump, and it actually takes in something. Jump takes in a frame, so let's put in a frame there. Okay, so let's save that, and now we should be able to jump in Unity. So let's go back to Unity. Oh, and we need to compile it. Always compile. Compile. Now go back into Unity. Right, so let's try that again. Alright, so now I can move around and I can jump, but the jump part is a little bit floaty. It's almost like, well, it's very similar to what you have in Unity. So we can fix this. If we look at our entity here, we have our entity prototype, which is our character, and it actually renames itself, but I know it's this one. And we actually have a config under character controller 3D. And we can open this config, and here we have gravity. So let's change that into -20, and yeah, we actually have to restart it, I think, for it to work. But if we're changing the gravity to -20, then we also need to change our base jump impulse to maybe 8. So let's stop that. And let's go again. Alright, so now it's a lot snappier and we are not jumping as high. We can actually jump up into this high ledge, but it's just barely. Alright, so now we have input and we have a movement actually working. But there is a big but here. If we take our character controller here, and we add multiple players like this, we will now actually be controlling all of them, because in our input we are getting player input 0, which is the first player. So he's gonna sort of control all of these characters, and in multiplayer it's not what we want. We want you to only be able to create or to provide input to your own character. So we need to figure out a way to actually resolve this, and it's something that Photon Quantum calls a player link. So we need to create a player link inside Quantum. So let's move over again to the Quantum side. So under input, let's create a new QTN file. So we'll call it player link QTN. And this time it's going to be a component, and we are going to call it player link. And in our player link, we are going to have a reference to our player. So we're going to go player ref player. Okay, so that's the only thing that our component player link will contain. So if we build this, we make sure that we don't have any errors. All right. So that looks okay. We have a success, and the QTN files was found. Okay, perfect. So now in our filter, we actually want only character controllers that also has a player link. So now we've added that filter, and when we are actually trying to get our input, instead of getting our input directly from player 0, we are going to get it instead from frame or filter, and then link and player. So that will fetch the player ref from this and provide it into our get player input. So that ensures that we are actually getting the local input from the correct player. and then we'll go back into Unity again. So if I would try the game now, none of the characters would move. And the reason is we've said now that in the filter that they need to have a player link, which none of them have. So if we look at our character controller, this middle one, we can see that, okay, we need an entity component of player link. So we can add our player link, check this box, and now we can specify which of the players it should be. So we have between player 1 and 6, and the reason why it's 6 is because this is the default quantum limit, but you can easily change that so that you can have, well, 20-30 players in a single room. But for now we're going to say that this center one is going to be player 1, the other one is going to be player 2, so let's add our player link. And the third one, we are not going to assign one, so we can see what happens. So if we try it now, we can see that, okay, we can only move our center player, and this third player doesn't have a link, so it's not in the game. And this player 2, well, it's not set up to use a keyboard, so it doesn't work. But our first player is actually working as intended. Now we have exactly 3 character controllers, but what if we are 5 players or 6 players? So we need to spawn these dynamically, and we can't do it from Unity because we need to do it from the Quantum side. But first of all, we need to create a prefab out of this so that we can instantiate it on Quantum side. So if we look at our resources, we have something called DB. And DB needs to be replicated, it's a database. And this is the information about the game needs to be in here. So our character controller entity, let's create a prefab. So it appears here. And then we can actually delete all of them from the scene. And then let's do quantum generate asset resources, just to make sure that it's updated. And then we can move into the Quantum side and, well, add the code for instantiating this. So we're gonna add the code here in our movement system. Maybe it should actually be a completely other system, but we're hijacking the movement system to also spawn and instantiate the player objects. So we have this public void on player data set. And we can see that it needs to implement a few things, but that's something we'll do in a bit. Here we go, on player data set. So we are getting the information about the player when this happens. So first of all, we want to get that data. So what we will do is frame.getPlayerData for the player, and we will store that as data. From this, we want to find our asset in the database. So we already put our character controller in the database, and now we need to find it so that we can create it. So how do we do that? Well, we go f.find asset, and then we need a type. So it's a entity prototype. Oh, entity prototype. And this then will take, what will it need? It will need a GUID, an ID. It needs to know exactly what object we are grabbing here. And from it, it will actually create a variable or return prototype entity. So we need to find a way of actually getting this GUID or ID of this specific asset. And how do we do that? Well, there is something called runtime player .user, which serializes data from a stream. So here's information about the ability to get information such as these things for the player. So if we look at runtime player, we can add a public Here we go, just need to make it at the right place. And again, the formatting is a little bit weird, so let's see. Here we go. So we will add a public asset ref entity prototype called character prototype so that we can access it. And we need to stream in the ID of it. So stream serialize and then ref character prototype ID. Then we have the ID of this, which is what we will use here. So in our find asset now, we can actually provide this information because it will be in the data stream, and then put it to the so that it's correct. So now we're getting the data.character prototype ID, which is supplied here. Okay, so now that we have gotten a prototype entity, now we've found it in our asset database, we need to create it. And we will then do a f.create prototype entity, which returns this created entity. So now as we have created our entity, we need to tell that entity which player it belongs to. So we will do that by getting the player link. So we will try to see if we can get it. So we go F, and then we are going to do unsafe, try get pointer, and the pointer that we are going to get is the player link, and that will need our entity ref, and it will provide out var player link. Hold on, I'm typing at the wrong place here. So create, there we go. Okay, so we are trying to get the pointer to player link and from the created entity, and it will be assigned to the variable player link. So what we do is we take our player link here, and the player, so the player ID or the player ref of this is going to be player that we are getting in here. Okay, that's logical. And then we are as well going to provide a position. So where is this going to spawn? So let's do the same thing, but instead we are trying to get the transform 3D, and out is going to be transform, and then we are going to say, you know, transform the position is going to be, and then we need to get some random position. So let's do a function get spawn position which takes in a player number. So let's provide the player to it. So this function does not yet exist. So this player ref is actually a number, so it goes 1, 2, 3, 4, etc. So we need a function that gets us a spawn point. So let's create a get spawn position function here that is going to provide a float point vector 3. And what did it take in? It needs to take in the player number. And it should return a new FP vector 3. And we want the players to start in different positions on the x-axis. So let's move it -4. So the first player is going to be way to the left. And then we add, and then let's say player number times 2. So for every player it's going to increase by 2, and then we actually need to add a little bit margin, +1, so there's a gap between each player. And then Y position is 0 and Z position is going to be 0. Alright, so now we're getting a spawn point here. Now the challenge is, or challenge, this on player data set is not going to get called by itself. It needs to be called by a signal. So how do we get signals? Well, we go to the top and we are going to say that we also want it to be iSignal on player data set. That is going to force it to call this. So if we store it now and go back into Unity, before that, let's compile. Always compile. All right, and now we go back into Unity and try it. It should work. So to be able to test this in offline mode or from the editor, we actually need to supply this data, because we are not launching through the menu scene, so there is no player data. So, but we have this quantum debug runner here, which we can actually load in some data. So let's add one player, and it takes in a character prototype here, which is exactly what we have. So let's drag and drop it there. Let's save the scene and yeah, hit play. So that should now spawn in a player, and no player. Oh yeah, we spawned it at 0, right? So yeah, here's our player. The camera is just not looking at it. Let's have the camera be here instead. Camera, game object, align with view, and then let's do it again, hit play. Alright, so here's our spawned guy, and it can move and it can jump. Yeah, awesome. In a later episode we'll fix the camera, but for now we're gonna keep it as it is. Alright, so what more do we have? We need to add support for online. So right now it just works here, but we need it to also work in the sort of when we're launching it in regular online mode. We need to make some changes to our menu. So let's go under Quantum Demo and Menu and open the menu scene. And in it we have quantum callbacks. So let's open the custom callbacks here. And in it we can see that the on game start is going to get called, and that will force it to send player data, which creates a new runtime player. But we don't want it to create a new one. We want it to use the one we want. So let's supply that, and let's do a public runtime player. And instead of the new one, we are going to supply the one that we are setting in the Unity editor. So now we can provide a runtime player. So let's save that and go back into Unity. Okay, so now we have a runtime player here, and we need a character prototype. So let's find it in our database, and there we go. So now we can save this, and don't forget to supply your quantum, here we go, resources, quantum Photon server settings, and here's your AppID that you need to supply in here. And then once you've done that, you can build it, and I'm gonna do that, and then we can take it for a spin. So let's start up our compiled clients. And it is important that we have unique names, so make sure they don't have the same name, otherwise you're going to get an error. So the left one is the master client, and then we have one client connected, and we can start the game. So here is our left master client, and as we can see, it's running around on both screens, and we can switch to the other client, and input and jumping is also working. Now there are a few things missing, like if our master client disconnects, everything will continue, but it didn't actually remove the character. So that's something that we will add in a later video, and same if we jump outside, it won't respawn, and also we can't handle like late joiners. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. This concludes this episode and I hope that you enjoyed it. If you did, please give it a thumbs up and hit that subscribe button and the bell to get a notification when the next video is out.